Ever wonder why the ground beneath us isn't as steady as it seems? It's because the Earth's crust, the outermost shell of our planet, isn't one solid piece. Instead, it's divided into large sections called tectonic plates. Imagine a hard-boiled egg. If you crack its shell, the egg remains intact, but the shell breaks into many pieces. That's a bit like our Earth, a solid sphere encased in a fractured shell. These tectonic plates, much like the cracked eggshell, are constantly moving. However, their movement isn't perceptible in our daily lives because it's happening at a geological pace, which is incredibly slow by human standards. These plates drift just a few centimeters per year, about as fast as your fingernails grow. But over millions of years, these small movements add up, dramatically reshaping the face of our planet. So the very ground we're standing on is a part of these constantly shifting tectonic plates. But what makes these huge plates move? Well, let's dive deep into the Earth to find the answer. The Earth's inner heat plays a pivotal role in the movement of these tectonic plates. As you may know, the Earth is like a layered cake. The topmost layer where we live is the crust, beneath which is the mantle, and further below lies the core. The heat being generated from the core of the Earth, due to radioactive decay, creates a fascinating phenomenon called mantle convection. Imagine a pot of soup on a stove. As the bottom of the pot heats up, the soup starts to circulate in a convection current. The hot soup rises to the top, cools down and sinks back to the bottom, only to be heated up again. This cycle continues, creating a constant flow. In a similar fashion, the Earth's mantle experiences convection currents. The intense heat from the core heats up the lower part of the mantle, causing it to rise towards the crust. As it nears the cooler crust, it starts to cool down and sink back, creating a cyclical motion. These convection currents exert force on the tectonic plates above, causing them to move and shift. These movements, albeit slow and measured, have profound impacts on the Earth's surface. When two plates collide, they can create mountain ranges, like the Himalayas. When they move apart, magma from the mantle can rise to form new crust, creating volcanic eruptions. And when the plates slide past each other, they can cause earthquakes. The science behind these shifts is complex yet fascinating. The Earth's inner heat, coupled with the mantle's convection currents, sets the stage for a mesmerizing geological ballet. All the mountain ranges we trek, the earthquakes we navigate, and the volcanic eruptions we witness can be traced back to these underlying processes. All these are simply the Earth's way of dissipating heat, with tectonic plates acting as the dancers on this global stage. In essence, it's the Earth's inner heat that's responsible for the dance of the tectonic plates. These movements aren't just for show, they have serious impacts. Tectonic plate movements are the unsung architects of our world. They shape the geography of our planet, creating the continents and oceans we know today. Imagine a world without the grandeur of the Himalayas or the depth of the Mariana Trench. Hard to picture, isn't it? That's the power of tectonic plate movements. When plates collide, they form majestic mountain ranges. When they pull apart, they create vast oceanic trenches and volcanic islands. But the influence of these movements extends beyond mere geography. They also play a significant role in our climate. The shifting of tectonic plates can alter ocean currents and wind patterns, which in turn influence weather patterns across the globe. So the next time you marvel at a mountain peak or enjoy a pleasant day, remember the silent, ceaseless movements beneath your feet. Our world's unique geography, from the highest mountains to the deepest oceans, owes its existence to the movements of tectonic plates. So what can we learn from all this? Let's take a moment to recap. Our planet, this magnificent globe we call home, is not a static entity. It's an ever-evolving marvel, thanks to the slow but constant dance of tectonic plates. These large, interlocking slabs that make up the Earth's crust are set in motion by the intense heat from within our planet's core. This internal furnace powers a conveyor belt of molten rock, pushing and pulling these plates in a geological waltz that has been going on for billions of years. As these plates collide, separate or slide past each other, they dramatically sculpt and mold our planet's geography. Mountain ranges rise, valleys form, and oceans shift. Moreover, these movements play a significant part in our climate, influencing wind and ocean currents, which in turn drive weather patterns. Tectonic plates, the Earth's living skin, continually shape and reshape our world, making it a dynamic and ever-changing place to live.